So we are going to be looking at a process for taking a KiCAD file and turning it into a Blender creation, which looks hopefully more like a PCB than this one. So we start with KiCAD. We're going to load a Proton C footprint, wire some stuff up to that. I'm drawing stuff here, but this isn't actually how you'd wire up like a keyboard or anything. If you're doing actual design, take a little more time than I am to do this. Trying to make something that looks complex, but really did not take very long to make. That looks pretty good, hopefully. We haven't actually looked at it yet. We'll load that from our schematic. Let's draw some outlines then. So that's looking pretty good. We got our stuff lined up here. So we can go ahead and try routing this. This is just connected to itself. Whatever. Okay, that's fine. These aren't even connected. Okay, yeah. Just kind of move these out of the way. These trace widths aren't the right size. But if you were looking for advice on how to actually make a PCB, this is not the video for it. So I apologize. What did I even wire that to? Oh, a pad. Oh, which is ground. Okay. Whatever. So let's just add some more traces in here for visual interest. Oh, don't forget your ground plane. Oh, yeah. We're going to set our drill, is it drill and grid origin, to the center of our switch here. And that should help when you export the step file. It sets the center as the center of your actual PCB. It makes it a little easier to work with when you get it imported and everything. We need to export this as a step file. So it might take a little while. If you have a very complex PCB, this will take a lot longer. Now it's done. So we can close that, and we're going to use Fusion 360. I think there's other ways to do this. I use Fusion 360 for everything else I do in CAD, so this is the program I'm most familiar with. You don't really need to be familiar with it. You're just converting a file. Okay, so that got uploaded. We're going to open that. This looks pretty good, and it looks like just like we did earlier. You notice that none of the traces are there. So we're going to fix that later, and that's going to be all in Blender. But for now, this is just, you know, where things are, and all the holes, most importantly. That's an important thing to have here. So from here, we're going to export it as a object, OBJ, and it's going to also take time. If there's a better way to do this, you know, feel free to use that. I just, this is what I was most familiar with. And sometimes if I'm working on design, I'll add stuff in here, like hardware components, or design a case around it or something, you know, which is obviously like the next step you do with something like this. But right now we're just going to focus working on the PCB and getting that to look nice. In the meantime, while this is happening, we're going to go back to KiCAD and plot this as SVGs. We're going to stick it in an SVG folder just to make things easier. We want everything but the edge cuts. We don't need that because we already have that in the step file. If you're a real design, pay attention to this stuff. But for the point of this, we're just going to use some basic settings here that'll make it look good. I think we're still waiting on Fusion. Yeah, but we're going to go ahead and open Blender. Lighting, you can do whatever. For this, I'm going to set it up so that we're in cycles. It works a little better with if you want to do emission stuff with LEDs and stuff, and you know, other effects. You could probably do this in EV too. For a lot of previewing stuff, we'll be doing it in EV. The world, we're going to make just all white. Give us a nice photo studio that we can kind of work in. So I'm going to make a plane for this stuff to set on. It doesn't really matter what size it is. We're going to start messing around with our monster shader that we're going to be building. So we're just going to call this, you know, PCB or something. It doesn't really matter. So we have SVGs, which is awesome because they're lossless and everything. Unfortunately, Blender can't use those as textures, so we have to convert those into PNGs or something that Blender can use. I hope eventually this isn't the case and that we can just import the SVGs into the textures, you know, like you would. And you know, it was like 10 years ago there was a add-on for this, or there was a modification to do this. Since then, I don't think it's been updated for anything recently. So unfortunately, I haven't gotten to work or anything yet. I'm going to be using Affinity Photo for this just because it's cheaper than Photoshop, and I already have it. There's tons of ways to convert SVGs into PNGs. For this, you got to remember that the size for the SVG is the whole like frame inside of KiCAD. So whatever you set the width to is going to be the whole width of the document. So you're going to want to make it huge. Like I usually like 10,000 is decent. If you want to do some really high def stuff, like even go higher. So it looks like our object is complete. So we can go ahead and close that, and we'll go into Blender and we'll load this in. And it will be pretty big and might take a while to actually load. And look at that, it's all one unit. It's also huge. We're going to rotate and orient this correctly. I think we'll scale it down to just like 10% just to make it workable. It doesn't really matter. If you want actual units, pay attention to that. Change stuff to millimeters and everything. But for the point of this, or for this stuff, we don't really need to worry about that. So I'm going to roughly line this up with the plane, and we can see that it's already starting to take shape. I mean, it is a shape. It's clearly all white. So that's what we're going to end up changing. So if we go into the modeling, we're going to remove the Proton C object, which is actually a lot of different objects. So I'm just going to go in here and hit L a bunch. And I'm just going to separate this for now. I could just delete it, but I kind of want to keep it in case I want to put it in later or something, or actually put like header pins on it, make it look like it will when you get it all together. But separate it by selection, call this Proton C, and hide it. Before we do anything else, we need to get at least one image in from our newly converted PNGs. So we'll grab our image textures. You can actually just select all of them and it'll load them in. And now you can choose from them. We do this so we can align the actual UV map here. So if we go to the UV editing, we're going to look at the top, select all, unwrap, and we're going to project from view bounds. And then in here, we're going to look at where we are in our actual texture. And you can see this is a very small portion of this picture. And I think you can change this with the page settings and get it more optimized for what we're doing here. But the good thing about this is they're all the same, like it's all the same size and they're all aligned, so we don't have to do any alignment between the actual layers. So once we align it here, that's all we needed to do. Once we have it unwrapped, I'm gonna just get rid of that window so it loads a little better. And basically, just align the center and then scale it down until things fit, really. There's a lot of tweaking that needs to happen here. You can try to look at like really small holes or vias or whatever these are and make sure that they're aligned and everything. So here we can see that this needs to come up a little bit. And a lot of it's just balancing between stretching and moving the object at certain points. That's good enough for what we have here. So before we do anything else, we need to separate our actual PCB. So we can just work on that, call that PCB, and we need to remove like the 40 different materials that this has, because we're going to be using one now. Now we're going to start building our shader. So we're going to grab the texture coordinate, grab the generated value here. We're going to separate our XYZ, and if we preview that, our Z, you can see how the bottom is black and the top is white. And that's what we're going to use to differentiate between the top and the bottom of the PCB. That way we don't have to have two different textures, we don't have to have two different planes or whatever, it's all the same thing. And the actual coordinate that Blender generates is going to change between the two. Okay, so look at this, we're grabbing our alpha component of each, because that's what's actually deciding what is important here. You can see that these are two different images on the top and bottom. And that's exactly what we want. I think we have these oriented correctly. Actually, no, they're backwards. Okay, so we need to invert this. I'm going to put this invert here, but you could just flip these around. This is kind of a dumb thing, but I want to keep the tops on the top and the bottoms on the bottom, just to make it easier to look at. And so when we do that, we can see that these pads for the sockets are on the right side, and then the vias are on the other side. I'm going to go ahead and group this. We can call this the copper decider. I hope you come up with better names. Yeah, so that's what's going to decide our copper stuff. We're going to be reusing the separate thing, so we're going to leave that for now. Do the same thing with the rest of our images. We're going to start with the mask, the bottom one as well. The mask looks pretty good. It's pretty simple in this case. And in some other cases, there's a little more interesting. But so the same thing here. We're going to group these. We're going to call this the mask decider. And then we're going to use our silk screen, front and back. So that's good. Group that again, and that's our silk decider. Okay, so these are what we're going to be using to switch between all the different shaders that we're going to be setting up. So usually with PCBs, the copper that is exposed is gold, so that's an easy one to do. We can use this principled shader we have here, and we're going to be having an entirely metallic. There's just two groups I'm going to be using. One is just the metallic colors. I think it's from Blender Guru, and it just makes things a little easier when you're choosing colors for metals. So that's our gold color. Looks pretty good. We're also going to be using this IOR specular computer. So they're supposed to be tied together. And the IOR is something you can look up, and I think it varies per material. Like for instance, gold, looking at the sheet I have on the screen, It's 470, and that will hopefully give it something that looks like gold. And so that's kind of it for the gold. We don't need much else besides that. So we're going to go ahead and group that and call that gold. And to make these easier to work with, I'm going to add a mix shader in line with this and then pass these two back. And so this is driving our gold basically. So we're going to do a similar thing with the solder mask. Solder mask is going to be, in this case, we're going to make it black. So the same thing here, we're going to use our IOR thing. I haven't figured out what the IOR for this is yet, but I think I'm using 1.2 in another project. I think I like the way that looked. Presumably if you're ordering these PCBs, you're going to be able to choose a solder mask. So black matte's pretty cool. You know, black glossy is pretty decent too. So that looks good. And we're going to group that. And we'll do the same thing here and just set up a mix shader that passes through. And with this, I'm also going to pass back the roughness, because this is something that can change. For roughness, the default value is what we had it at, and I think that's good. But depending on if there's copper under your solder mask, it'll change it slightly. It'll be like little, I have a PCB here that we'll be referencing later on to try to figure out like the little tiny details and everything. So it looks good. So we'll call that our just solder mask, I guess. Silk screen, really it's just white material. It doesn't really matter beyond that, just because it's such a small part of the whole PCB. You don't really see a whole lot of it, but we'll go ahead and make it look somewhat accurate. I think this should have like a 1.4 or something. I don't know. It doesn't really matter. I think it is a little shinier, so we'll drop that down and then just do the same thing here. Okay, so we got 3 textures here, 3 deciders, and to get it all set up, there's going to be like decision making. So first, you have to look at where the solder mask is. That'll basically decide where the gold is visible. So we can throw that here and then throw our mask decider into the fraction. I got it backwards. Okay, so with this, let's just copy our invert and throw it there. Yeah, so the mask is a little different because it's showing you where the mask is in. So that needs to be inverted. Everything else I think is normal. So first we're gonna do silk screen, because the silk screen sits on top of the solder mask. Yeah, that looks right. Okay. I didn't arrange the silk mask to look nice, but that's fine. Everything is fine. We don't have to worry about anything in this too much. We're going to be taking this setup and adding some displacement to it. Now the displacement, you don't actually have it to, you don't need it to be the correct displacement. Like you don't need to do actual, you know, displacement only or displacement bump. You can just use the bump. But we're going to be just routing this separately instead of through all the materials with normal maps and everything, because this needs to be independent of the actual shader that's being used. And that's because like the copper changes the way the copper is displaced, makes, you know, the solder mask higher even when the solder mask shader is showing and the copper is not showing. And so that's basically how we get all of our traces and everything on here. So we're going to use the same deciders from here and just use a displacement box. I don't know this node, but displacement node that's going to get hooked up to our output. So as a quick demo, we'll just plug this into the height. Like, oh yeah, that's how it's supposed to look. You know, that sort of thing. The scale on this usually needs to be turned down quite a bit. I think I use 100th, 0.01 on this. But basically, each of these things, decider things, has its own value, or has its own height that we're going to add into this. So rather than adjusting it here, we're going to leave that back at 1. Use 3 math nodes to multiply, and then add them together. It seems like this add function should be something that could just have as many values as you want. I guess multiply too, I don't know. This seems like that would be a neat feature, I guess. So copper is the thickest thing here. So that's gonna be our largest number. And we might end up changing some of these. Like it's kind of hard to tell, but whenever there is a solder mask exposed, so here you can kind of see the pixelation here. So if you're going to use a render this close, you'd want to use a higher resolution. So you can play with inverting these and seeing how it changes. We're also going to turn off clamping because that will mess everything up. Between this area here and this area, there should be a little tiny gap. And there we can see a little tiny gap. So, and then the silk has a little bit of a height to it as well, but that looks like it's a little strong. Also in here, instead of using the world, we can use this other world, the built-in HDR, which gives you a little more like in place look, I guess. So yeah, there's a little bit of texture there. So the roughness thing I was talking about, we're going to grab the copper decider and use that to change the roughness. So basically this goes between 0 and 1. We can use a color ramp to decide what those values are. So when there's no copper, how does this look? There's no copper, it looks a little shinier. So that's going to be a lower. When there is copper, it's a little more rough. Like, it's a pretty subtle thing, and you can make it more extreme too if you want. But here is a good effect where you can see like the difference. I think it looks pretty, kind of a little too much maybe. Just to get a little more difference. So if you're like, you know, makes it a little more realistic. So also for this material, this looks pretty simple, right? Well, it can get a lot more complicated here because basically all of our edges are kind of messed up, right? It thinks that they're, you know, part of the top when they're really sides. We're going to use the z-coordinate again to figure out where the sides of the material are. We're going to be using that as or determine which sides of the edges and render those differently. So we actually need another material in here. Well, we need another decider too. So let's go ahead and make that first. I've been messing around with this a lot, and the thing I found works the best is like a highly translucent, like you're basically getting fiberglass. Because if you look at the side of a PCB, it's kind of like this yellowy green, and obviously you can see through it and stuff, but you can also see holes that are very close, so you kind of want to be able to see that. And obviously the roughness and everything can vary based on which side it is, but we just want something that will, you know, convince us at a glance of that's what it is. The IOR I've also been experimenting with. I think 1.2 is good for what I was doing. So if you look at the side, that's what we're expecting to see. You can kind of see the holes. That's kind of what we want. Color-wise, green color I think is what I ended up on. Something like that, yeah. Maybe a little less saturated. Just dialing it back a little bit. I also messed around with like the subsurface scattering. I didn't really like the results I was getting, and obviously it's a lot more intensive on everything, so I just kind of skipped over that. We can also add some texture to it. The way I did that was a texture, or a checkered texture, and I use this to control the roughness. So I use a vector math from a texture coordinate. So we'll route that into there. That will give us enough. It's really subtle. No, you can see it. Yeah, so that's good. So you can also route that to a displacement here. And this we're actually going to do in the normal. I guess, I don't know. I'm not sure if it matters. So it looks pretty good. Okay, so that's our whole thing. So what are we going to do here? We're going to grab this, going to group that, set up another mixture shader, and we're going to call this the edge, PCB edge. It's like the raw PCB. Really, it can go on the top too. Obviously, you don't want that stranding, all that in there if you're going to put it on the top. But you can actually get like PCBs without that on it. I don't think the ones I designed, like usually the solder mask covers all those spots. But if you intentionally put that on your PCB, you can definitely use that to your advantage. And I know with like clear, if you use a clear solder mask with like a different substrate material, like we did on the Proton C, we used the black substrate with the clear solder mask. It looked kind of cool. So the PCB edge material looks good, but now we need to work it into our whole decision stuff here. And so to do that, it's a little more complicated than what we're doing earlier with these deciders. So we're going to subtract 0.5 from this, and that'll give us this like middle line here. We're going to grab the absolute value of it. So now we have basically 0 to 0.5. And now we can make multiply by 2. And now we have 0 to 1. Not that that really matters. This doesn't really, we don't need this for a whole lot. We're going to use another math node to ask if it is less than 0.9, going to be a hole, basically, or the edge. That is our decider for the edge. So we call that edge decider. So the edge is the first thing we should be looking at, I think. So one caveat of doing it this way is that some of the silk screen comes down the edges here, which can kind of look weird. Maybe we'll fix that later. So one issue with this is that right now, even our plated through holes are a PCB edge, which is not what we want. So in addition to our edge decider, we also need to look at our copper to decide if these should be plated in gold or not. So we need to add a math node to this to multiply it by the inverse, I think, of our copper decider. Yeah, those look copper to you? Those look copper. Or gold, whatever. Okay, so that's good. Yeah, obviously a lot of this stuff you can tweak, and if you have physical PCBs, like that's going to be your biggest, the biggest way to kind of figure a lot of this stuff out, just by looking at it and looking at your thing. And it helps to have like a similar light setup too. So if you know that you have like one source of light, like set it up in here so you can like compare it, directly and see how it looks. Some of these, like this footprint is all weird and wonky, so some of the stuff is going to look weird. So yeah, this looks pretty good. The bending's kind of straight. Usually when they cut PCBs, like you can see the actual like pattern in there, so it's not going to be perfectly straight. You're going to see like some striations and stuff. So that might be something to consider, like maybe add some rotation to this, so like there's a diagonal pattern or something, or you can go crazy and add fingerprints to the PCB and everything. One caveat for this is that we do have our paste mask layer we didn't use. I haven't figured out a good way to actually simulate like the soldering, liquid material that would like cling on to stuff, because it would only cling onto the coppers, it wouldn't cling onto the solder mask area. I think that'd be a cool thing to do, but I don't have that set up yet. So eventually when I get that figured out, I'll do a separate video on that. But for now, you can either model it yourself or just don't worry about it, or just call it a bare PC without components, or whatever you want. Yeah, obviously if you're making a case or whatever, you can pull that in, you can add textures to it, you can make it look real, you can add it to a scene, you can use actual design. So yeah, that's the process I've used to make some of the renders for my products and everything. If you check out the link to the GitHub in the description, I'll have links to the KiCAD and the Blender file. I have the materials and groups in there that will hopefully be useful and you can use on stuff. So, all right, thanks for watching.